Hi, this is Miss Hamilton, and we're going to talk about finding the area of triangles. The essential question for this lesson is, what is an efficient way to find the area of a triangle? The word efficient meaning quick and easy. The Common Core standard for this lesson comes from the geometry strand from 6th grade math. And we're going to focus on the first part here, find the area of right triangles and other triangles. Our vocabulary for the unit area, it's the number of unit squares that cover or are contained in the shape. Our base is going to be one of the sides of the triangle. It can be any side. Often it's the bottom side. You can rotate the triangle so that is the bottom, but it is one of the sides of the triangle. To find the height, our other vocab word, the height, it's the perpendicular distance from the opposite vertex to the base of the triangle. Basically, it's how tall is the triangle, or if you were to drop a rock from the opposite vertex, which way is it going to go and how far? It is usually not one of the sides. We started off with finding the area of a triangle by counting the squares. We found it to be a little difficult and frustrating because you had little bits and pieces of squares. You had to kind of put them together and figure out where they went. So then we tried drawing a rectangle around the triangle. We knew how to find the area of the rectangle by knowing the length and the width. So in this case, it's 11 and 12. The triangle makes up half of the inside of this rectangle. So I could find the area of the rectangle by multiplying the length and the width, and I would get, in this case, 132 units. But my triangle is only half of that space inside, or half of that area inside. So if I take the 132 units squared and divide them by 2, I will get the area of that triangle. Now, it's not so easy to find the rectangle that you can draw around all the different sorts of triangles. So I'm going to show you how to find the area by identifying the base and the height that we defined earlier. So looking back at that right triangle, this is a right triangle because it has a right angle here, that lovely L angle. It's 90 degrees. We could find the base is the bottom. In this case, it's 12. And then the height is going from the opposite vertex down. If I put a rock up there, which way would it fall? It's going to head straight down. That's what gravity tells me. So here it is 11. It is one of my sides. I'm going to take my base and my height, multiply them, and divide by 2. So 12 times 11 gives me 132. I take that 132, divide it by 2, and I get 66 units squared. So we can find it by multiplying the base and the height and dividing it by 2. This is an acute triangle. An acute triangle looks a little bit different. All the angles are less than 90. You don't have that nice, neat little square corner. All of the angles are less than 90. In this case, the height is on the inside of the triangle. So imagine if you had a rock at the top. Oh, wait, we don't want that rock. We want this rock. Okay, so we have this rock at the top of our triangle, and we're going to drop it. Which way is it going to go? It is going to go straight down. That's what gravity tells us. So it forms this height in the middle in yellow. So notice the height is on the inside. Now, if I were to count and see that the base is 10, and I would count the height, it is 9, I can follow the same steps. Multiply the base times the height. 10 times 9 gives me 90. Divided by 2, I get 45. That means that the area of this triangle is 45 units squared. Another type of triangle is called an obtuse triangle. An obtuse triangle has one angle that is greater than 90. It's this big, wide, or open angle. Notice here my base is at the bottom, but my height is outside of the triangle. If you had that rock, there's the rock on the top again, and I drop it, which way is it going to go? It's going to go straight down. It's not going to go crooked. It's not going to go to the side. It's going to go straight down. So my height here is on the outside. In this case, my base, if I count it, it is 7. The height is 5. I'm going to do the same thing. Multiply that base and that height, divide it by 2, and I get my area of 17 and 5/10 units squared. So we can create a formula that we can use for any triangle. All we need is the base and the height. I can take the base and the height, multiply them, and divide it by 2. Another way we could rewrite it or reword it is 1/2 times the base times the height. Either one works, because remember, multiplying by half is the same as dividing by 2. So our formulas are going to be A equals BH divided by 2. Area equals base times height divided by 2. Or we can say it as the area is equal to half BH, or 1/2 times the base and the height. So in summarization, you need to identify the base. Pick any of the sides, doesn't matter. Usually the bottom is where you're going to go, but you can pick any of the sides. Find that height, find that vertex opposite it. Which way is that rock going to go? It's going to go straight down. To use that rock, remember your base actually will have to be at the bottom, thinking about gravity. You're going to multiply the base and the height and then divide it by 2. So the formula we're going to use is base times height divided by 2. Again, you could reword that as 1/2 the base times the height. So that's how you find the area of a triangle.